For my project, I'm going to look at the relationship between swine population and water pollution in Iowa. I live in Iowa and I'm very curious about the impact that the hog industry has on water quality. Iowa is an agricultural state. It ranks number one in the United States for producing corn, soybeans, hogs, eggs, ethanol, and it also ranks fourth in beef cattle. Iowa accounts for almost 30% of all the pork that is produced in the United States and tallies more than 20 million pigs and hogs in its recent inventories. To put this in perspective, Iowa comprises less than 2% of the land area in the United States, and almost 90% of its land is used for agricultural purposes. So, what impact does hog farming have on Iowa's water quality? And what will the exploration of the number of swine per county versus water quality parameters show? And I just want to point out that this term parameters is not the statistical definition of the word parameters, but the Iowa DNR uses this term parameters to describe the water quality data that it collects. So I use it as well. We know that land use impacts water quality, and agricultural land use is a non-point pollution source that can cause high level of nutrients such as phosphorus and nitrate to get into the waterways through fertilizer and through animal waste. And if we look at how much waste hogs actually do produce, here is a graph that I found from a hog farmer article based on research done by two different agricultural researchers. And the black line is the older data. It's traditionally used. It's about 20 years old. And this newer data, this red line, has been augmented according to newer data within the last 5 years. But anyway, regardless of which line we use, we multiply these gallons of waste per day by 20 million. That is a tremendous amount of waste that is being generated by the swine in Iowa. If we look at Iowa's waterways, here is a slide from the Iowa DNR that lists the impaired water in 2018. And there are two keys here. The streams look like streams, and then the wetlands and lakes are just indicated by little squares or circles. The category 5, which is the red, means that the impairment is significant enough for the DNR to change it and to fix it, whereas category 4 means that the EPA does, or the DNR does not need to remediate it. And we see here in the key that there are quite a number of impaired waterways, 673 in category 5, 152 in category 4 for the streams alone. This is a slide from 1998, 10 years earlier, and 20 years earlier. And it's a little hard to compare because the color coding is different, but it appears that the level of impairment has increased as time has gone on. It looks like 2018 has far more impaired waterways than 1998. This slide shows the main watersheds throughout Iowa. And not only does Iowa have these different watersheds based on the different rivers that flow throughout Iowa and the geography of the terrain, but there's a lot of difference in terms of soil type. Many areas in Iowa have very high water tables and they're more susceptible to nutrient pollution than other areas that have lower water tables, where the water would get filtered before it reaches the aquifer. So as we look at this impact of number of hogs versus water quality, what data can I actually access in this amount of time that I have to do this project? So water quality is consistent independently assessed for streams in 41 of 99 Iowa counties. And although there's also wetland and lake data, the stream data is the most plentiful. And the Iowa Agricultural Census publishes county-wide data for number of swine or inventory of swine every 5 years, with 2017 and 2012 being the latest data. Iowa has a lot of streams, over 72,000 miles of streams. So I'm curious to see the difference between 2012 and 2017 in the water quality, looking at the Iowa Census, agricultural census data. Between 2012 and 2017, there was an 11% increase in swine, from about 20 million to almost 23 million. And there was also an almost 10% decrease in number of farms. So these farms are becoming consolidated and larger in this 5-year period. I wanted to look at inorganic nitrate, dissolved oxygen, ammonia, and E. coli because these are parameters that are measured by the DNR. Several counties had 2 or more water quality collection sites. So in that case, I averaged the data for those more than one sites, and I also averaged the XY coordinates. This is absolutely convenience data. And one thing I want to point out is the average area of the counties, of the 41 counties that I use in the study, have an area of approximately 590 square miles. And the distance between the swine farms and the water quality assessment sites are not known. That data just was too difficult for me to get to in this short amount of time. But the data is known. The DNR does have those locations, so it is possible to do a more detailed study where we can determine water quality based on distance from these swine farms, the water quality in the streams. Also, geography, hydrology, and other land use factors, such as the crops that are being planted in the county and the other animals that are being raised in this county, definitely impact the overall water quality, and they're not considered in the study at all. So there are some detriments here to the study. So nitrate is an essential plant nutrient, so it's found in fertilizers and it's also found in manure. So both crops and animal farming can contribute to high nitrate levels. So if we look at this slide from Iowa DNR 2000 to 2008 overall average, we see high levels of nitrate in the northern central part of Iowa. This part of Iowa is relatively flat. It also has a lot of row crops. And it also has a relatively high water table, and many agricultural tiles are used to drain water. This area used to be sort of marshy before it was farmland. If we look at the average between 2000 and 2014, we still see some high levels of nitrate in the central area of Iowa, and then we also see high levels beginning to show up in the western area. Dissolved oxygen is a parameter that I thought might be interesting to study, but it turns out it was a poor choice to compare because those values depend on the temperature and the time of day, and those were parameters that I didn't look at. And all the values that were reported were above 5 milligrams per liter in every single county, so they were not any areas of concern. Ammonia levels were also not a good, were also a poor thing to study because their levels were so low and they did not vary too terribly much between counties. Many of them, well, not many, but about 5% of the values were below the detection level. So ammonia was a poor choice. But the E. coli values did vary. They varied from year to year and sometimes even within the county. So if we look at the relationship between nitrate, E. coli, number of swine, I'm going to use scatter plots in Excel to identify relationships between number of swine, E. coli, and nitrate. Use an ordinary least square analysis through ArcGIS to identify spatial relationships between the E. coli, nitrate, and the swine throughout the state. And future studies could include multivariate regression to tease out impacts of crops and other animals, as well as looking at the actual distance between swine farms and the water quality assessment sites. So here's my preliminary data: number of swine versus inorganic nitrate in 2012 and 2017. We see higher levels of nitrate in 2017, and we also see perhaps a relationship here between the number of swine and nitrate. The number of swine versus number or the amount of E. coli seems to be a little bit more scattered, and also higher levels of E. coli in 2017, where we have the higher number of overall swine. And then nitrate and E. coli, there seems to be a relationship perhaps between those two. So I'm excited to show you the spatial data in my final project.